What's up, goblins, and welcome to my newest guide in Cosmoteer. Today I want to talk about everything about heat management. Heat is the newest resource that got introduced into this game with the recent Meltdown update, and oh boy, there are so many new things I want to talk about with you today. Okay, so we will go through some basics. I will then cover also some do's and don'ts, and after that we will head over to some more advanced topics like the new weapons that we got into this game, and also one very interesting thing, heat exchange between your own ships. This is what I want to talk about today to make you feel comfortable with this new topic. First of all, if you haven't played this game for a while, or you're a new player, you might ask yourself, but Gobbo, where on earth is all this heat coming from? So, with this new update, we got two major sources of heat. The first source is the enemy is shooting you and applies heat to your hull. That's the first thing. And the more interesting thing, especially for us, is the heat we generate ourselves, especially with overclocked buildings. Overclock is a new mode you can apply now to buildings. It's optional, you don't have to overclock your buildings, but you can apply this to your buildings to enhance various status effects of your buildings and give them extra effects. I will not cover this overclocked mode in detail here today, because this is just way too much. Almost every building has an overclock mode now, from thrusters to shields to all kinds of weapon systems and so on and so forth. And so this is too much to cover here in this guide. Just keep in mind we have these two major sources. First, enemy shoots you and you have heat. Second, you shoot or you do something with your overclocked buildings and this also generates heat. Alright, now that we know where all of this heat is coming from, of course we need a way to deal with all of this heat, right? So let's start with our first topic, the basics. Before we start talking about all these new structures here, I want to point out two things now that we are in the building mode. So in the building mode, you can now find, it's called heat stats. You can find this in the right corner, you see over here. And if you apply these heat stats, they will show you the heat generation for your ship, the heat dissipation for your ship, and the heat capacity for your ship. And if you want to build anything around the heat management, you now have a designed tab only for the heat management here, where you can find all of these structures I'm going through here now. The first part I want to talk about here is the most common one you will find in every single ship. The heat pipes, exactly. The heat pipes are necessary to conduct heat throughout your entire ship, and they come into three different variants. First variant, normal heat pipes. Second variant, also normal heat pipes but with structure as a background. And then the third one, very interesting, the heat pipe crossing. This lets your crew cross from the left to the right side. But also keep in mind that the heat pipe crossing can only connect to another heat pipe or to any heat output in a straight line. They are not able to do this in all four ways like the normal heat pipes or the heat pipes with structures. The second structure I want to talk about is the radiator. The radiator is pretty straightforward. It simply dissipates all of this collected heat into space. So each radiator, if we have a look here on the description, has a heat dissipation of 1100 megajoule per second at a maximum. Why at a maximum? If you build any kind of structure in front of your radiator, it will lower its output. To make this efficiency even clearer, I now made a small example here for you. So as you can see, I have some armor tiles in front of our radiators in various lengths. So the first radiator is not obstructed, has an efficiency of 100%, and then we go further, and you can already see at 37.2% that efficiency is shrinking by a lot. So the only exception that you can build in front of your radiator is the casual structure. So if you want to build something around your radiators, make sure it's structure tiles. The last thing I wanted to say about the radiators is the possibility to run your heat from the left to the right side. And this is a very rare exception. Most buildings they are not able to run heat from the left to the right side. This is indicated by this by this yellow V you can see here in the middle right now. So this is the sign that this building is able to transfer heat from the left to the right side. And with this knowledge, we now go over to our first showcase ship. Okay, with this first showcase ship, I want to show you how to connect all your overclocked buildings correctly to your heat grid. And if we go in here, inside our heat management tab, we can now already see these little yellow dots. Yellow dots next to a building indicate that you're able to place heat pipes there, and they will automatically connect to this building. So now, why is this wrong here? Why did I mark this with an X? The problem with this building is that we don't have a connection between the middle part of this middle engine room and the other engine rooms, even though there is one heat pipe. As you can see here, there's one heat pipe and they are connected to both engine rooms on both sides. The heat is not able to run through the outer engine rooms, which means that our middle engine room will over time overheat. And you can already see this because the engine room lacks this V-shaped sign here in the middle. This means that there is no heat transfer between the left side of the engine room and the right side. So what you have to do instead is you have to connect all your engine rooms down below here with heat pipes so that all of this heat can be then transferred inside your radiators. One more thing, if you want to overclock your buildings, you can simply select them and then you will find this little overclock button on or off here, and the game will automatically already show you where the possible heat pipe connections will be. So most of the time, these heat pipe connections are also equal to the door locations, just as a rule of thumb. There are some exceptions I will talk about later. Back to the basics. So the next structure is the thermal battery. A thermal battery, also pretty straightforward. This lets you store thermal energy. To be precisely, 15,000 megajoule is the maximum capacity of one thermal battery. And the thermal battery also comes in with, as you can see here, two possible inputs. And as this V shape already indicates, you can also use this to connect, for example, to independent heat grids if you want to. Now you might ask yourself, but Gobbo, why on earth is this thermal battery important? I mean, I can just build more radiators to radiate all the heat and then don't need thermal batteries at all, right? But the thing is, thermal batteries do have one very important application. They become very important if you have high outbursts of heat energy throughout your ship. And I will show you now with another small experiment what I mean by this. Okay, for our first little experiment, we will nuke a ship. Yay, finally some action. Okay, so what's the experimentation setup? So we have on one side an overclocked large shield generator. So the large shield generator is very impressive. It has a shield strength of 90,000 points, which is double the amount of a normal large shield generator. But it also generates heat passively, 80 megajoule per second. And on top of that, it also generates heat when it gets damaged, 0.6 megajoule per damage. And there you can already see, if we deplete this shield strength very fast and we apply all of this damage at once, this is 54,000 megajoule at once. This is clearly enough for some few radiators here. You can see this, I have two radiators here. I also try to redraw the direction of the heat flow here with my with my little design here. And on top of that, we also have some thermal batteries to store all of this extra heat. 4 thermal batteries in total means we can store maximum of 60,000 megajoule. So just barely enough to hold these this complete shield generator. And now I will show you what happens here if we nuke this thing. So you can clearly see the nuke dropped, the shield generator is immediately depleted, and our thermal batteries are full under the roof. Really, they are completely full. You can see this here. This is the load status. And compared to before, it's completely full now. So if you have very high outbursts of energy somewhere, very high, you might need a thermal battery. I will also show you now what happens if you either don't have enough thermal batteries or if you just have no thermal batteries at all, the outcome is the same. So what happens if we nuke this for the second time? Bam! The second nuke hits the shear generator, and you can already see the shear generator is heating up big times now. Watch what happens if I let this simulation here run a little bit longer. Zack, we see fires spreading around our shear generator in high speed because our thermal batteries are full and the radiators cannot keep up with this pace. And you can already see the shield's HP is dropping big times and fire started to spread everywhere inside our shear generator. So you always want to make sure that if you have one high outburst of energy on one location, for example, if you have very large shield arrays, that you have enough thermal batteries available. And second, that you always have enough radiators to get rid of your heat. Remember, you can always see the heat dissipation as well as your heat generation on the other side. But keep in mind that this heat generation means the passive heat generation of your buildings, not these maximum outbursts, for example, of your heat generators. Alright, so much about our thermal batteries. Now I want to hop over to our last basic structure, and that's the heat exchanger. Exactly, heat exchanger does exactly what it tells you. It exchanges heat with its environment. So if we have a look on the heat exchanger, it comes with a radius, so it does not, of course, indefinitely capture heat from the area just within this red highlighted area. And the heat exchanger is able to absorb 900 megajoule of energy per second. And on top of that, it also has an absorption inefficiency of plus 40% heat. So keep that in mind. If you absorb stuff with your heat exchanger, you always have this absorption inefficiency that will pump even more heat inside your system. So the heat exchanger is pretty useful if you have some small overclocked building inside a tight location and you cannot run a pipe there in this location and you want to capture this from a little bit further away. The heat exchanger is also very good if you build them inside, for example, your outer hull to prevent your outer hull from getting overheated by enemy weapons and such on. Just keep in mind that the heat absorption is very limited and also you have this absorption inefficiency. I think we now covered the basics in full length, so it's finally time to hop over to some more interesting matters, namely the new weapons that got introduced with the Meltdown update. With the new update, we also got blessed with two new weapons. Namely, on the left side, we have the Thermal Resonance Lance. And we also got a new missile type, the Thermal Canister Missile. You can see this here on the right side. And I want to start by talking about the Thermal Resonance Lance, because this thing is a little bit more complicated. The Thermal Resonance Lance outputs a big, enormous heat ray. So this Thermal Resonance Lance is meant to heat up the enemy hull or the enemy interior. It's not so much against shields, it's very effective against armor or interior parts. And if we have a look onto this, the Thermal Resonance Lance also comes with two new amplification modules. First thing, the Lance Dilation Pump, which increases the area of effect of the thermal lance. The second module is the Lance Amplification Pump, which then enhances the output of the thermal lance. So one thing I should already notice here, you can always apply your Lance Amplification Pumps and your Dilation Pumps everywhere in your entire grid. You don't necessarily, you can connect this right next to your Thermal Resonance Lance, but you don't necessarily have to. You can also connect this far further down the road. It does not matter. And the second thing I should note here, they not only increase one single Thermal Resonance Lance, they increase every single thermal lance on the same grid. And this is very important because the efficiency of your connected modules on this grid decreases with the amount of thermal lances. This is the first noticeable thing. Second, the heat output with each thermal lance on the same grid increases. And third, the power consumption also increases with each connected thermal resonance lens, and this leads to a few problems I want to show you in my next chip. To understand these problems, I firstly want to show you two ships. They are almost the same. The only difference between two ships is this first ship over here has 3 completely independent heat management systems, while the second ship, down here, the bad bomber, exactly, has a whole heat grid. Completely everything is connected. And yeah, as you're able to see here, we have 3 thermal resonance lenses inside this ship here per heat grid. They are completely independent. We have one section over here, one section over here, and then one down here. This is way too complicated to show this in detail, but I want to mark here one thing. Look at the heat generation and the heat dissipation. Now, keep that in mind. We have 80,000 heat generation. If we now hop over to our completely connected design, we now see we have 150,920 heat generation. Why is that? There's no difference. It's the same amount of weapons. It's the same amount of amplification modules. Everything is the same. The only difference is in this ship, we have this whole heat grid connected, which means each of the dilation pumps, each of these amplifiers, everything in this ship has to support not 3, but in this case, 9 thermal resonance lenses at a time. As I told you before, the generated heat with these modules increases with the amount of thermal lenses you have hooked to your same grid. And this is already the first problem. So the first problem is we have enormous heat generation because instead of 3 thermal lenses, we now have to support 9 thermal lenses. The second problem is efficiency. So if we have a look now here, we have a dilation of 497% and 2068% amplification. Sounds a lot. It is also a lot. This is a lot of amplification for sure. But if we hop over now to our first ship, we have 368% dilation and 1267% amplification. Sure, this is less than the other ship, but keep in mind that in this case, we have 3 completely independent grids. And this means if we, in theory, connect all these grids together, we should have, if we keep the same efficiency, right, we should end up with something like 3,700% amplification, but we only end up with 2,000% amplification. And this is because our efficiency decreases, because we now have to support 9 thermal lenses instead of 3. So, but this is not only your biggest problem right now. The biggest problem is power. Okay, so let's have a look on this. Why is power our biggest problem? If we now have a look on the lens amplification pump, we can see that we have a power use of 0.4 power per lens per second, which means with 9 lenses hooked to this one grid, our power consumption for every single module is over 4 power per second. Every single module throughout this entire ship. And see how many modules I have here in these sections. So we need, for every single module, we right now need a whole medium reactor just to power this one single thing. And that's why power consumption is our biggest problem here. So to summarize this, why is it good sometimes to cut your grid and make it independent in multiple ways? It's good if you have multiple thermal lenses in your ship. It's good because you can maintain your efficiency with your modules. It's good because you can keep your heat at a manageable rate. And it's good because you can drastically reduce your power consumption. Drastically, trust me. The second weapon we got here is the thermal canister missile. The thermal canister missile explodes at the enemy's hull and applies heat to it. On top of that, it's a very good long-range weapon with 450 meters range. This is one of the longest ranged weapons in the game. And there are some very noticeable things about this. So the thermal canister missile does not only need parts from your thermal canister missile factory, no, it also consumes heat, exactly. 7,500 heat and 5 parts from your factory missile are needed to launch one of these things. And this is very interesting because this makes your thermal canister missile a good addition to deplete heat from your ship, like the radiator. It's also good to store heat, like the thermal battery, which gives you then more options for your heat management. And this is extremely efficient if you have many high heat generating buildings in your ship, like for example the thermal resonance lance. Exactly. One more thing I should say here is that the canister missile is one of the few buildings that can also let heat pass through it. You can see this here in this V-shaped sign. Now that we know everything about the new weapons, it's time to hop over to our last topic for today, heat exchange between your own ships. And this is a very interesting one. Now you probably ask yourself, but Gobbo, if you have two completely independent ships, how on earth do you conduct heat between those two ships? And the answer is pretty simple. Radiators and heat exchangers. Okay, let's go through this. So, step 1. You need a ship that has radiators facing the second ship that is connected with your first ship. If you don't know how to connect ships in Cosmoteer unmodded, I have a dedicated guide only about this topic already on my channel. I will make a link for this in the description. So yeah, this is the first step. You need radiators facing your ship right behind these radiators. They have to be very close, the radiators. The closer the better. The second thing is you need heat exchangers on your receiving ship. You can clearly see here we have some thermal batteries here, a radiator, but there is no single building on this ship that is overclocked. There is no building that is connected to my heat pipe other than my heat exchangers. And so there's no way that this ship could generate any heat whatsoever. So all of this heat really in this case comes from our radiators. So when is this useful? This is useful if you have not enough space with your front ship, for example. You don't want to expose too much of your area to enemy fire or so, and so you need some area for your radiators to put them, right? So what you might then do is you put your areas on the backside, like I did here, and then conduct this through the next ship behind your actual ship that you want to cool down. The second reason is, in theory, you can use this extra heat on your second ship to then produce exactly thermal canister missiles. So in theory, if there was no... Wait. I'm gonna get rid of this. In theory, we can also now build some thermal canister launchers here, right? Which means even though we don't generate any heat on this ship, we can still use this extra heat to then produce some more weapons on our second ship. So these are the two major applications, and I now want to show you how this looks like in the practice test. Just as a little side note, in theory, just in theory, very theoretically, you could even use the radiators as a weapon to heat up enemy ships as well. So this not only works with your own ships, of course, you can also heat up enemies with this. But it's very impractical because you have to fly very close. You need a lot of radiators to make this very efficient. And you then have to, of course, expose your radiators. You cannot hide them behind armor or something like this. So this is more of the theory, but in theory, it is possible to abuse this as a weapon. Okay. Now, let's go over to our experiment. How does it look like? So it's pretty much the same like before. We have our shield generator, we have our thermal batteries here on the first ship to tank all of this generated heat. And then we have our two radiators, this time facing right into the face of our next ship. One more side fact here, funny side fact. Even though the radiators in this case are obstructed, right, you can see this here, they are obstructed, they still have an efficiency of 100% because they're not obstructed by the same ship, right? They are constructed by a second independent ship. That's why this method here works. And we will see now what happens if I launch a nuke here. Okay, as we can see here, the nuke hit our sheet generator. The sheet generator is empty. Like before, we can already see our thermal batteries are completely full and our radiators are on full load now. This is, by the way, the effect that you can see when a radiator is hitting the surface right behind it. But don't be fooled, the radiator is still working at 100% efficiency. And now what you can see on the second ship is that we have our heat exchangers here sucking up all of this heat. There's a little bug here. I don't know why it tells me to repair and then not repair all the time. I think this is a little bit of a bug because, of course, this is this is not intended. But yeah, you can clearly see that even though we don't have any heat generation method on this second ship here, our thermal batteries are charging slowly and our radiator here is working. There are a few things you have to keep in mind to make this work. The first thing is your heat exchangers can only absorb 900 megajoule per second, right? So you need always more heat exchangers than radiators. The second thing I want to mark here is that your heat exchangers also have this absorption efficiency. So keep in mind that through this absorption inefficiency, you will apply a little bit more heat into your pipes than you're actually outputting with your first chip. Alright, this is everything I have to say about the heat management system. If you want to support me and you like this guide, or of course, if you have critics and say, hey, there's some part missing, let me know in the comments. That's it from my side now. Just keep in mind to build enough thermal batteries and radiators to not set yourself on fire. And I'll see you next time. Bye bye.